So in this video, we're gonna use Slint to program a little microcontroller attached to the screen. I have here a webcam, VLC showing my webcam, and this is the little device, and this is some interface written with Slint. And this is running on a Raspberry Pi Pico RP 2040. So this is not a Raspberry Pi one-board computer like the other Raspberry Pi. This one is really a microcontroller. You cannot run Linux in this. You only have 200 something kilobytes of RAM. So I said kilobytes, not megabytes or gigabytes. It's really, really small. So how do you program this kind of things? We're gonna use Rust, and we're gonna use this from this project called RPRS. They just have a project template. So in this video, I'm just showing how you would use Slint if we do not really support Slint. So we already support this thing, but imagine we don't. We could work on any microcontrollers attached to a screen, and this tutorial we're just gonna use this RP2040 as an example. So I'm gonna clone this project. Let's clone the tutorial. And the README explains what you need. So you need to install Rust, obviously. So I already have all of that installed, and a bunch of other things that you can use cargo install to install. And normally you will just run it, but there is a bunch of runners. So this runner use probe, RP probe, which is fine, but it needs your Raspberry Pi to be connected to a probe. In my case, I don't have that, so I'm just gonna use this one. So I open the project. Yes, I trust the authors. And in cargo config, I'm gonna use this runner. Okay, let's try cargo run. In the meantime, I need, of course, to connect my thing, and I need to press the button here while plugging it in. So the code compiles, and it runs, and we have a blinking LED, blinking LED, and that's because that's what the code does. If I open the main RS, what it does, it sets up a few things, and then it makes the LED turn on and off. We want to now attach this to a screen, so we need a bit more than a LED. So I'm gonna attach my things to this screen. So what screen it is? This is a screen from Waveshare. Here is the spec. It uses this control chip is the ST7789. Luckily, if I search for the screen on Rust, it's already supported by Rust. So I'm gonna use this driver, this ST7789. So I'll just go to cargo to mail, and add this crate. Yes, so how to use this? Well, we'll check some of the examples here. Let's just take some example, and we'll just copy this as a. So it's not for the Raspberry Pi Pico. It's for some other things, but we'll see how this goes. And in main.rs, we'll add this here. So what we just added, we had the core already. So the core peripheral we already had. The delay, we didn't have the delay. So we keep this. And this is not the same. It's not gonna be the same. So what are those pins? Those pins are supposed to be what is connected to. Here we'll go back to the screen documentation, and they explain here that the LCD is connected to somehow the GPIO 8, GPIO 9 for the select. The backlight is on 13 and stuff like that. So we take them not from this thing, we take that from the pins. So the backlight is the GP13. The pin GPIO 13. The LST is the GP15. Pins GP15. The CS that was chip select GP9. And the DC GP8. Pins GPIO8. What about CLC clock and MOSI? So 10 and 11. 10 and 11. So this originally was from another chip, so now we want to work with the Raspberry Pi pico, so we need to change a bit how it is. It doesn't use a level in and I don't think we have the grade here with this. Okay, for the SPI, this is a bit, I think there's an example there, so we can go to RP-HAL here. They probably have examples. And there is an example with SPI. So we'll take this. So those are not the same pins. Into mode function SPI. That seems like what we should actually do for the other those other pins. And then we can create the new SPI like this. And we need also the MISO. And the MISO is gonna be on MISO is gonna be on GP12. And we don't actually gonna use this, so we just set the pin in the right thing, and then this does the rest. Then we're gonna initialize our little thing here, and we're not gonna this is gonna be 60 megahertz, so the screen with a higher frequency. So HAL, we're gonna just import HAL BSP HAL. So that was from the example, which we don't need. We need to initialize our screen with a display interface. So we need a display interface. So that's another crate that we are going to add in the cargo 2ML. interface SPI. So let's see what the version we have here, 0.4. SPI interface. So we're not going to use the non-CS because we need the CS. We have it there anyway. It's because the chip select is the same bus that controls both the touchscreen and the display. So we need to one with a CS. Then we create the display. We can import this. New with I think the new API need an option. We also need an option for the backlights. Blacklight. And then the resolution of the screen. In our case, it is 320 times 240. Very well, so we initialize. We're gonna set the orientation in landscape. We're not gonna load an image, but we're gonna clear it not in black. Let's say red. Do they even have red? I think. So this is using the embedded graphic thread. So we also use embedded graphics. To the latest. So now we can import. I think not yet. Let's import embedded graphics RGB 34. Oh, we don't need that. We're just gonna blink on it. So now, and that is maybe not best. Let's try blue. Okay, let's try to run that again. I'm gonna show the screen. I misspelled used. Let's fix that. Use. I'm gonna use show the thing. So again, I'm gonna plug thing while pressing the button. Blue. So I've used embedded graphics. Use embedded graphics preludes. Everything from the prelude. Okay, more errors. Well, we're gonna use can we import this? There is no megahertz. We should inherit it. I think this is coming from another crate called Fugit. So this is coming from another. It's called Fugit. Edition of the thing. So now we can import use Fugit rate x32. We try again. It's the backlight, not the black lights. Can actually see if there's error. Doesn't need to be mutable, so then remove the mutable. And let's try again. And now it worked, it's flashing, and it didn't, so it's blinking, but it doesn't show anything on the screen. So that's, yes. So what's wrong here is that it's SPI1 that we want to connect to, not SPI0. So let's try that again. Let's reset the device while pressing the button. Aha! Now we have the screen in blue, which we want. And if we wanted to have it in red, we can put it here in red. So we have a working device. Red. Working device. I need to make it so that we see everything on the screen at the same time. So now that we have a working device, what can we do? Let's put it in black. Again, black. So again, I need to reset the device and run it. Yes, so now it's black. So now we're gonna use Slint. So in order to use Slint on microcontroller, we have a documentation here in the documentation of the Slint crate, and they explain how to use Slint on microcontroller. And the way it works is that just you use Slint, you have a build.rs that is gonna build the Slint language, and then we're gonna integrate with what we have now. So let's do that. First, let's go in our extensions in VS Code and get the Slint extension. Let's install the Slint extension. Okay, this is installed. So now we can create a new file. Let's call it main.slint. And let's declare our main component like main UI, and it's a window. We're gonna specify the width of pixel and height of 240 pixel, and we'll put a background, let's say blue. Okay. And now we can show preview, and we have a preview of this. Let's resize the window so we have both on the same thing. I'll use white. Let's use white, and then we're gonna use a button. So buttons needs to be imported from this under a widget. So import button on the widget, semicolon, and then we're gonna use this button. We'll put a text to it. Hello. Yeah, there it is. So the button is full screen now. We don't want that. We'll put that into a layout, vertical layout. Let's have two buttons or a text. First, there will be a text. Hello on Slint. So the syntax is that you declare elements and you can give elements properties. So we have a button with a text hello from Slint, a button with a text hello, and then we're going to change the alignment of this layout. alignment. We're gonna add some spacing, 20px, padding, 20px, hello from Slint, and here we have a little UI, and we're also gonna use about Slint, which is a widget which we provide, which has a little image and something like that. Okay, let's try to put this UI now in Slint. So let's go back to our documentation. It says, let's copy paste this. In cargo to mail. So what happens here is that we're using Slint with the version, and it should be the same as the build version. We need to disable default feature because by default Slint uses the standard library and we're using bare metal, so we don't have the standard library, but we need to enable those features for it to work. It's explained in the documentation what those features are for. Then we're gonna make a build script. There is already a build script, perfect. So we're gonna take this build script and we're gonna copy this. So we're gonna call this compile with config of the Slint build crate. And we're gonna use an option which is embed for software renderer so that the image are built in and the image and font are built in into the binary. And that's it for the build script. So now we need to use here Slint include modules in main.rs. So that's just gonna include the generated code from our Slint build. And we need to implement a platform trait. So this window is using the minimal software window from the Slint renderer. So yeah, so this 2 here is the number of how old the last frame that is on the screen is. And that is important because we're gonna just do partial rendering. So when you do double buffering, you want to refresh things that have changed in the 2 last frames. Here we do not use double buffering because we do not have enough RAM to hold a buffer. So we're gonna use 1 because we want to have the change since the last frame. A timer, usually we use a timer here. That's exactly what we need. And so that's the platform which we're gonna implement the platform trait from Slint. For my platform. So the thing that we need to do is to return the window. So there is only one window, so we're just gonna return this one from here. And there's other functions that we need to implement. Probably is the duration since start. It's for animation. It's important that we know. So there is no time. We don't use the stdlib, so we do not have a way to get the time. We need to feed the time into Slint, and that's how we do it, by looking at what the timer returns. It's the time in microseconds. We'll initialize that later. Run an event loop. We're not gonna run an event loop like this. What we need to do is to initialize the windows, set up the UI, and we'll copy this. So we have our black screen here. So we're creating a new window. We're setting the platform to my platform. Here we need to initialize the timer. So the timer is initialized. It's a HAL timer. What does it take? Pack.timer. And set. So that's how we initialize a timer. And this uses box, but we do not have box. So we need to, because we use no std, so we do not have box by default. So we need to import it into the use. And this reminds me that we still need to set an allocator. So in cargo to mail, we're gonna add an allocator. The allocator we're gonna use is the alloc cortex n 0.4.2 alloc cortex n. For example, see examples global alloc. Okay, let's go to this repository. Examples global alloc. Let's just copy paste this. So let's copy paste this in the beginning of the program. We just initialize we're gonna need a size of, let's say, 200 kilobytes. And because this needs a error handler and this is still not stable, so we need to use unstable Rust. Unfortunately, this might be soon stable, but before that, you will still need to use the nightly Rust. Where was I? So this name is coming from what we have here in main.slint. So we call it main UI. So it's called main UI. New. Set up the UI. Set the size on it. Okay, what else does the documentation say? The event loop. So let's just copy this. And remove this blinking thing. I mean, we could, no, let's remove the blinking thing. So, first we need to let Slint to update animations and timers. We'll come to the touch events later. Then here is, and then we'll sleep later. We'll just do an infinite loop for now. Draw is needed is what we need to do something here. See next section about rendering. So there's two types of rendering. Either we render into buffer, so just render into memory, but this can only work if we have enough memory to hold a buffer. And a buffer here would be 240 times 320 times 2, because it's 2 bytes per pixel. So that's already 153 kilobytes. And I do not have, we could hold a buffer in memory, but then we would not have enough for the rest of the UI and everything. So what we're gonna do, instead of generating in a buffer, we're gonna generate in a line. line by line, and then we're going to send those pixels to the screen line by line. So let's copy paste. So this is an example that uses embedded graphics, so it's perfect. Let's just copy paste this. Let's copy this a bit up. So we have something that wraps a buffer and that has a line buffer. So it's for one line. It's going to be an area where we can store one line of rendering. Okay, then we implement the line buffer provider from Slint for the straight from embedded graphics. For anything that can draw on a screen which use RGB 565 as a color. So basically this is gonna also work for our pico. So we just call the render function that is given as a callback that will render things into our buffer. And then we're gonna call the fill continuous function from embedded graphics to just run on a rectangle that's bound for one line. So it's like a rectangle of length 1 for what we need to render. And the color comes from the line buffer, which we need to map to OU16. Okay, let's try to compile. So now I need to use nightly Rust, which I already have installed, and I'm also gonna use the release flag because it's gonna be faster. But this is not finished. I have still this to do here, which I need to do. So in draw, it's needed. Okay, I'm gonna use here. So we instantiate a line buffer here on the stack. We can instantiate it here. Here our display width was 320. Some error. So our build.rs, it's not UI/, it's just main rs. So that's just a small thing to fix. Let's continue building. Where were we? Line rendering. Here, drawing needed render line by line display working. That's it actually. That should be working. Let's see. What are the next error? Put it in SRC. Why not? Can choose where we put it. I'm gonna again reset this while pressing the button. No method get time. And I don't know why Rust Analyzer suddenly is not working, but maybe it is here. Failed to run build script. And I thought we fixed the build script. Anyway, we're gonna just follow what the error message here says to use box. Extern create alloc. Extern create alloc. Embedded graphics. Oh. I think we can just reuse. So embedded graphics is split into a core and a non-core, but we can just use the full one. Here we use the full one we don't actually need for Slint, we don't need we could use just embedded graphics core, but now that we have the full one imported, I would just use the full one. Okay. So RC is also not declared, but it's alloc RC. I wonder why Rust Analyzer doesn't show any more errors. But those are just some spelling mistakes, which I don't want to know about. Rectangle new. This comes from embedded graphics, I suppose. I think there was a line of things I need to import here. We already had preludes, I thought. Apparently not. Okay. What else? Row U16. We have it there. Defined multiple times. Yes. Allocator not found. I thought I had copied from there. Need to have this. Okay. More errors. Get time. Get time does not exist. What is there? Get counter. Okay, Cortex heap not found in this scope. Thought it was. Let's import it. Timer. Timer new. Okay, we're getting there. A few warnings. Alloc error handler. I thought it's the I will use the default one, which panics when there is a failure. And I think now it compiled. Transferring to pico. Let's see if this works. And there we have it. It's reverse, but we have here our button and our little thing. Of course, this is still not working. You can still not press the button because we didn't implement the touch screen. So let's do that. Let's implement the touch screen. So the touch events is going to be a bit more involved because we would need to find out what's the for the touch control. So what's remaining to do is now the touch controller. So I'm gonna go here in the template, which it's a bit of a cheating because this template is already made for the Raspberry Pi Pico, and it has an implementation of the touch driver here, which I'm gonna copy paste. I'm gonna just copy paste this. in here. So this touch driver use SPI, and basically what it does, it will read the command that it needs to read on FPI and read the value of where we are currently touching it. And so I will again copy paste it. What I'm using here is actually, I'm using a different SPI, which is the shared bus. I need a shared bus because in this version of embedded HAL, this is how you share the SPI. The same SPI is used for both the touchscreen and the display. But what I'm gonna copy paste is this touchscreen. Doesn't matter where we put this here. So we create this thing which we just copy pasted, and we need also one of the pins goes in it. Then we need the SPI using the shared bus. Shared bus. Version. Yes. So the SPI here, I'm gonna shared bus manager simple new for the SPI. And here it uses this SPI. We call SPI acquire SPI. So here when I click, it becomes a bit gray, so I want the same to happen. In my event loop, I had commented out something. Here, check for touch event. Again, check from touch event. We'll copy paste again what I had there. Yes, so we have our touch, we read from it, and then we create a window event based on that and based on what the last touch is. So we need to also declare our last. So the last touch is just the location of the touch as we detected last, and if there was a location before and there is not anymore, then that means that it was released. Otherwise, it means it was a press, and we dispatch the event. We dispatch the event and we don't continue. We just dispatch that event, a press or a release or nothing if there was nothing. And then we're gonna draw. Okay, let's try this. I will some error. Window event was not declared. We need to import it. I wonder why customizer is not showing stuff. Yep, I need again to reset the device while pressing the button. Up, we are flashing it with cargo run. And now we can check if this works. So if I press the button becomes gray. So it's not very visible here in the camera, but if I press it, it changes color. And now what we will do, so the LED here is off. We want, for example, to use this to turn a lamp on and off. We are gonna go in main.slint. This button, we're gonna say clicked, and we need to add here a callback. Button, for example, clicked, root, button clicked. And with that, we can main.rs, we can set up the UI on button clicked, which we just added. Go back. So we're gonna move here. Let's move. It's gonna move this LED pin, which we still have. And what we're gonna do when we're pressed, we're gonna set high. So if LED pin is set high, we'll set high. Pin set low. So up again, I need to reset this. There are some errors. Expected bool on result. So this cannot fail anyway. Yeah, it's flashing the pico. Now we have a little UI, it's upside down, the LED is off. If we press the button, now the LED is on. Press the button again, now it's off. So that's it. So we can also imagine instead of like a button like this, we can try to have a bit of a fancier button. So I call that a toggle. Height 100 TPX. Pull back. Yeah. Let's use this here. Property text. Okay, so it's gonna be horizontal layout, horizontal layout with text. Which says hello. We're gonna rename that into toggle LED. And then rectangle with 25%, color blue. We want to have, yeah, so it's not color, it's background. Background blue, base same px. This is gonna be like a, let's make it actually gray. Border radius height divided by 2. So we have like a thing like this. With, it says 100 px. Merge 50 px, yes. And height 30 px. Like this, and then another rectangle inside white. Oh, this rectangle, let's have it so height is gonna be a bit smaller than the parent height minus 4px. 2px, y 2px. Just make a little toggle here. And it depends on property bool on. If it's on, we want to be at the other edge. So parent dot width minus 2px else 2px. And then we add also a touch area. Clicked. So when we click, we're gonna toggle it. So on equal not on, and then we put clicked. On. Yes, that's great. Let's make an animation. Animate X duration. Let's make it slow. 1 second. Yeah, that works. And we're also gonna change the color. If it's on, it's gonna be blue. Otherwise, it's gonna be gray. So, and we're gonna animate that as well. Like 0.5 seconds. Animate background. Yep, so it's a bit prettier. Let's just try that on the device. Again, I have to press this to reset the device. So it's in the mode where it can be flashed. And we flash the device. And let's see if animations are working. So now we have our little checkbox here, and if I press it, it animates. It's yeah, we made it a bit fast. Let's say 200 milliseconds. Enough. 200 milliseconds. Where is my thing? Still quite slow. 100 is probably enough. And we want easing ease out. There and there. Not there. There. Okay, this is a bit different animation. Let's try that on the device. Again, I need to reset it. There's some unused stuff, but that's okay. And it's gonna come there, and now we have, if we press it, we have like a nice hidden animation for this thing. And that's just, I'm gonna stop the tutorial here, but of course this is less than ideal. So one thing that is a bit slower than it should is the way we refresh. We go by, we code fill continuous. So after we just rendered our line in a buffer, we could fill continuous with embedded graphics, and this is not as fast as it could be, because what we could do here, this little chip has a DMA, so we do that in the actual Slint. There is some code that in the actual Slint there is an example in MCU board support for this pico, and here what we're doing, the line on the byline or buffer provider here is using DMA to, so it swaps the two buffer, renders into one of the line, and then send the line to the screen, and when that line is sent to the screen, it renders into another buffer for the next line, and then does something in parallel. But this is a bit out of the scope of this tutorial. So that's it for now. We just made our little thing. The demo with the MCU is available in the examples. So if you want to check, you can check those examples in Slint and how to compile the printer demo that we have for the device, and you can get inspiration on what to do there. Okay, that was it. I hope you like this tutorial. So you can go into slint.ui.com and check Slint out. Thank you.